Now that we've gone through creating load cases, as we just did, we created the dead and the live and the 4 wind load cases. Let's move on to the load combo tab over here. And the load combo tab does not come with a default combo. It's completely empty. And you need to build from scratch. Now, first, I'm going to show you how you can create load combos manually. Like I said, there are two ways. You can either create load combinations manually, or you can request the program to create these load combinations for you automatically according to some um, basic load combination given in the standards. So now we're going to talk about creating load combinations manually. Now, as I said, it's empty, it's unpopulated. So you begin by pressing this create button. And when you do that, an undefined combo is created. And this is the first combo. And we can change the name. So we can call it, say, dead only. We can give it any name. Or we can call it D if you want, just so that maybe it looks more like a generic name. We can give it a comment. The combo type is a linear add, or it can have different types. It can be linear add, absolute add, and envelope of maxima. These are different scenarios you can use for combining the results of the load cases into the load combo, and they all might be required. So we're going to stick with the linear add one. Now, we'll talk about these in a second, but let me first begin by defining it. So what we do is these are load cases which we just created. In fact, this list on the right not only has the load cases which we just created, but also has this very combo which we just created over here, and we can use that to actually include combos inside combos. So what we'll do is we won't include a combo inside a combo right now, but we're just going to select the dead load case and press this arrow over here. And when I press that, then it means that this dead load case is included in this combo D. And the factor of the dead load case will be 1. So it's basically this combo is just the dead load. That's the combo. And that's the way I'm going to make another one called, so if I press the create button again, now I've got another undefined combo, and this one I can call dead, for example, dead plus, I can say, so I can press the plus button and I can say L. So I can give it the name of D plus L, for example. Once again, it's a linear one. And I can now, from this list over here, I can add the dead one and the live one. And I can say that the dead one should have a multiplier. So maybe this one dead has a multiplier of 1. And in this one, we've got two load cases now. And we can say for the dead one, I want a multiplier of, say, 1. Say 1.4, and for the live one I want a multiplier of 1.6. So these are the factors, these are the multiplying factors which we use in load resistance factor design, for example, when both the loads are factored and the resistance is also factored. But what the basic idea is to create this load case and then add the create this load combo and then add whichever load cases we want to add. So the next step would be to say press the create button again, and this time say D plus L plus, obviously you can give it any name you want, say wind, but this time you want wind X, for example, wind X, that's the one you want. So in this case, what you will do is you once again select dead into it, live into it, and wind X into it, and you'll give them their appropriate factors given over there. So let's keep them consistent. Let's call that 1.4. Let's go, sorry, this one should be 1.4. Or maybe with the win one, we need to keep all of them as 1. So let's revert them back to 1. And now this is my dead plus live plus win X combo. I can press create again, and this time I'm going to give it a name of D plus live plus wind minus X, for example. I can call it that. And in this case, I'll include dead and live and wind minus X into my combo, and I can keep going like that. So this is the basic way of creating load combinations manually. Now, obviously, this gives you complete control, but this is also a bit tedious. And we'll get to in a few moments. We'll get to how to actually. So what? How many did I would have ended up with dead plus life, and then four of these: dead plus life plus wind x, wind minus x, wind y, wind minus y. Had I had four earthquake combinations, there would have been four lines for that. Had I had some crane moving in, there would have been maybe hundreds of lines for that. So I want a method to actually create these using the indices and sub indices which we talked about. And we'll get to that in a second. But before we do that, I just want to talk about these little checkboxes over here which we have, which are very important. And that is that each combo which we have can have any number of these checkboxes checked. So when we say use for stress check, so when I select this combo and I say use for stress check, I'm telling COMOSYS that this combination needs to be used for designing the profiles and their stress checks. So as we know that every element is supposed to pass two types of tests. Basically a stress check, which in itself is basically composed of axial loads and moment stresses and shear stresses, etc. So, and there's also a deflection check. So do I want this combo to be used for deflection checks? It's up to me. I can select that combo and I can say also use it for a deflection check, or I can say that don't use it for a deflection check. For the deflection check, I'm going to give another combo, but in that combo, I'm going to uncheck this one and check the deflection check, for example. So it's completely in my control which combo will be used for checking stresses and which combo will be used for checking deflections. Similarly, you can use any combo for connection design, and that might be a different set of combos. So because we will be doing detailing as well, and we'll be connecting the members as well, and most of the major macros in COMOSYS do design checks as well. So they will tell you whether that connection is failing or not. But it needs to know which particular combinations to use for the connection design. So you need to select this particular checkbox if you want this particular load combination to be used for deflection checks. Similarly, you can use a particular one for concrete design, for foundation design, for stress contour envelopes to show the stress contour envelopes on the screen. They are pretty self-explanatory. This one is interesting. This one is element specific, and when we do that, so you can have an element specific. If I call this particular combo to be element specific, for example, and I say use for stress check, what this means is do not use this combo for any element. So normally, if I don't check this box, all my combos, all my load combinations will be used for designing the elements. Each and every element um, in the building will be checked against all those load combinations. But if I specifically say that this particular load combination is element specific, then the elements in the building will not be designed for that. So it'll basically be overlooked. I will create this combo, but this combo will never be used. Now the question is, why do I create a combo which will never be used? And the answer is, let me just close this. And so I've checked this one to be element specific. This dead plus live plus wind minus x. I've checked it as element specific. And then I can, just to show you, I can select any particular member. So I can select this beam, for example. And what I can do is, I can, if I go to my, let me see, it's design detailing definitions, design one, design two, yeah. In the design two tab, I've got that particular combo which I marked as element specific. And now I can say, I can take this one and I can take it to the left. And what this will mean is that as far as dead plus live plus wind minus x is concerned, just forget about it. Don't use it in the design of anything, but only use it for the design of this beam, which I've just selected. So this is an element specific combo. It's not applicable to all the other elements. For the other elements, this combo will be completely ignored. And this is useful when you're dealing with specific so for example, when most standards will say that they will want you to use a particular wind load for the entire facade. So they will say that for the facade up to a height of, say, whatever, 10 meters, use a wind pressure of 50 kilograms per square meter or 80 kilograms per square meter. That's for the whole facade. But then they will also add that for individual girts, use a slightly higher load, not 50, but say whatever, they'll multiply it by a factor. Now the question is, if you apply that load to the, if you apply that higher load to the girts, then the entire building will be loaded with a higher load, and that's not what you want. You for the entire facade you want a lower wind load, but for individual girts you want a higher wind load. So in those cases, what you will do is you will specify element specific combos with maybe higher factors or different loads inside them or whatever you want. But you will basically use element specific macro load combinations for the girts, and then normal loads on the same girts, but in non-element specific combos this time, so that the building is loaded with the normal loads, but the girts are designed with the slightly higher loads. So this actually really helps you a lot, because normally the way people will handle the situation is they will create separate models, one model only for the girts and one model for the rest of the building, and then another one for the purlins and this and that really breaks down in the sense that you don't have one model which actually covers everything, and you have to divide your finite element model into several parts. So this is quite useful, this whole idea of element specific macros. Let me just remove that uh, and go back to my load cases, go back to my load combos. So I selected this and I checked it as element specific. I'm going to uncheck that because I'm not going to use element specific combos in this example. But the whole idea is that you can create element specific combos, and then you can assign those combos to individual elements. You can assign them to the first floor beams. You can assign them to the girts on the left, on the right, or whichever facade you want to. And this will basically help you in not being forced into dividing the model into many subparts for all these little tricks you need to play.